welcome to sine waves and why it matters to electronics. My name is Mike McCarran, and I'm here to talk a little bit about sine waves. So, I have a couple of objectives with this. I want you to be able to look at a sinusoidal or a sine graph a little bit differently. And I hope you gain a little bit of an understanding about radio frequency electronics through the process. Uh, Sine waves are everywhere, and this is kind of what they look like. The graph, the mathematical graph, is sine of x, and it's basically a wave shape. We call them sine waves because that's how they flow through the air or how they flow in electronics. Um, so here's a couple things they're used for. They're used in all everyday real life applications. Music, anything that deals with sound uses sine waves, ballistic trajectories. Triangulation uses sine and cosine, and a plethora of other things. It's kind of interesting. So I used to always think that as a young person, I used to always think that this was a useless concept and I would never use it again, right? I'm sure we all did when we took algebra, and I'm definitely no different. But as I got older, I saw more and more that I was using them and using them and using them. For example, in electronics, I'm an electronics technician. Uh, I work on all sorts of electronics, and this is just an example of a light circuit. Basically, your everyday AC for your house is actually a sine wave, and that's how we actually get to be able to measure it. This is what it would look like. We measure it in several different ways, such as amplitude, which is the voltage level, and wavelength. Wavelength is where we get frequency from. 1 over wavelength is actually the formula for wavelength. Amplitude matters because that's where we get how powerful, say, sound waves are. Wavelength is where we get pitch from, if you want to talk about sound. Um, and we use this all the time. So there's two ways to measure waves, and I'm going to be talking purely of the time domain. And if you don't really quite understand that, this is just for people who actually have seen it quite a bit, and to kind of base everything I'm going to talk about today. Um, where are they in electronics? Well, watches use them for timing. Radios use them to actually receive and transmit. Same with cell phones. Computers use it for the input power. I mean, sine waves are everywhere. It's kind of ridiculous. So, mixing. So, I'm not talking about baking. The everyday electronic mixer is just a way to combine two signals. And I'm going to speak about RF purely here. So you have an input signal such as music or voice, and then you mix it with another signal, and that's how you get your sound to your radio. Uh, the output of a mixer is some difference in the two originals, and so when we transmit it, we do a summation, and when we receive it on our radio to listen to in our cars, we actually take the difference and we get our music. So modulation is the process of putting that information together, of mixing it together. And there's two terms that I'm going to be using. Information, that's the voice, music, what have you, and the carrier wave, which is what is used to go over the air. Think of it like the post office. Amplitude modulation is the process of taking and mixing it and varying your carrier wave on an amplitude. And so that's how they actually get it for the AM talk radio. This is actually what it would look like if you took a O-scope and looked at the signal. And remember, mixing, you get the sum, the difference, and the two parts. So this would be on the transmission side because we're getting a sum. Mixing is everywhere, and that's kind of the big thing about sine waves. I mean, that's how they're used. So you have the information, And there's also frequency modulation. Frequency modulation is the process of varying the frequency of a wave, sort of like amplitude modulation, where you vary the amplitude, and that's how you can transmit over the air. So the reason why modulation came about is because lower frequency waves actually can't go over the air because they get stopped by weather, atmospheric effects, whatnot. So we mix it with a much higher frequency carrier wave, and that's how we get our music to our radio, actually. This is exactly what it would look like when it gets to you. So timing, these are what are called crystal oscillators. So you put in a voltage, and they actually output they're quartz crystals, and they output a frequency signal, a sine wave frequency. And they use that in everything electronics because everything has to be able to talk on the same time base. For example, inside this watch takes an AC signal. It's a AC watch, you know, like you plug into your wall, and it outputs you the time in a digital matrix. Um, so it's taking that exact same thought, and it uses a crystal to do that because that's how it works. So I hope you get a little bit about what happens and why we use sine waves, and I hope you enjoyed this. Um, Thank you so much.